Okay, good day everyone, and we are going straight to number 5 now, still on the previous exercise 2.6 that we're looking at. So number 5 quickly and number 6. So this episode is talking about 5 and 6, still 5 and 6. So before proceeding, ensure you like this video and the previous video. Do well to have subscribed to this channel and share to other friends that you have and colleagues, to your WhatsApp platform and everywhere that would need this video important. So now let's go straight to number 5. It says determine the component of the force. Now straightforward, you should understand the formulas, and the formulas will make you go straight to the point. Now for you to find component of force or components, of any vector, are you getting now? You need to understand that the components of the force in the direction of a vector is equals to that force, or whatsoever this force could be interchanged to be a vector A, and this one could be interchanged to be vector B. So in whichever one, you should know that it is what the first one dot the second one over the first one, the magnitude of the first one. So indirectly, what the formula is meant to be for component of force, the formula is supposed to be written as a vector A dot vector B over vector B. So it could be in the direction of vector A. Sure, you understand? So whichever one, just know that the one in the direction is going to be the one under. So just like projection of vectors. So that's literally what we're talking about. Just without like wasting of vectors time. So without wasting time, where we just need to go straight to is to the understanding that our force was given from the question as stated as that's minus 3i plus 6j plus 2k. Then let's just assume our vector A. Yes, so assume it's A is minus 4i plus 4j plus 7. So we already have our force and our vector given. So straight using this formula, this is another formula you need to take note under vector. And our components for this question is going to be, this dots is referring to what we call scalar dot products under the product law of vectors. So that's meaning that for us to solve this part, we'll be using what we call scalar dots principle. So here we'll be having minus 3i plus 6j plus 2k dots minus 4i plus 4j plus 7k. So there is a video on scalar dot products method. You can check in the description button, then you will get to see that. So for also an explanation to magnitude, this simply means magnitude. So for us to find magnitude also has a formula. Magnitude of A, so of this A vector, of vector A, let me just put it like this, of vector A. Now the formula for magnitude is this: square root of all your displacement, I square plus j square plus k square. So that is how how to find the magnitude of a vector. So here we'll now be having square root of our A. So meaning that we'll be having minus 4 squared plus 4 squared plus the magnitude of all the displacements, 7 squared. So straightforward, let's just do this. Now how do we multiply using scalar dot product? We use this to multiply this, we use J to multiply J, then we use K to multiply each displacement for each direction. So each displacement for each displacement direction for this direction. So then this will be having this times this. So this times this, minus 3 times minus 4, that will be plus 12. I dot I in scalar dot product is equals to 1. So that's 12 times 1, that's 12. Do we get that now? So let's go to the other one. Plus 6 J times this, that's 6 times 24, that is plus 24. J times J, that's J dot J is equals to 1, so that's times 1. Then let's go to the other one. 2k times 7k, that's plus 14. Then k times k is 1, that's k dot k is equals to 1. Don't forget this. Then all over the square root of, let's make use of our calculator. So here we'll be having minus 4 squared plus 4 squared plus 7 squared, that's 81. So straightforward, let's add all this together. Let's add this quickly together. 12 plus 24 plus 14, that's 50. So here we're having 50 over square root of 81 is 9. So the components of this question is going to be 59 divided by 50 divided by 9, that's 5.6. That's the answer to this question, 5.6. So let's go straight to the number 6. That's just how it's being solved. Everybody just understand this formula, then you know how to solve the principle of scalar dot products, and you know how to solve for magnitude, then you are good to go. So let's go to the next one, which is number 6. Number 6 talks about, it said find the value of A. I'm looking for A when vector A is equals to AI, this is the given, and this is the unknown, minus 2j plus k. Then vector B is equals to 2ai, meaning this is our unknown, minus aj, this we also have the unknown here, plus 4k. So they said they are perpendicular. Okay, these vectors are perpendicular, and you remember that perpendicular vectors, the product of two perpendicular vectors is equals to 0. That is, A dot B is equals to 0. It is a rule on a scalar dot product. Scalar dot product. When you multiply two perpendicular vectors together, their product or the answer or their result is always equals to 0. So take note of that. Okay, so let's go further. So meaning that when we're having this times this, we'll be having it equated to 0. So meaning that ai minus 2j plus k dot 2ai minus aj plus 4k equals to 0. So the same way we did this, how we multiply in scalar dot product. This I for I, j for j with their sign, don't forget, and j to k to k. So this with this, so simply means we're having ai times 2ai. That's, let me put it out here, ai dot 2ai. Fine. Then minus 2j dot minus aj, then plus k dot 4k equals to 0. So that's literally the way it's being multiplied. Dot scalar dot product. So straightforward. A times 2 times, there is an unknown here, that's 1, that's 2. Then a times a, that's a square. Then I times I, that's I dot I, that is 1, so that's times 1. Then minus 2, minus times minus, you have plus. 2 times 1 literally is 1 you have here, so that's 2. Then your a, j times j is, that's j dot j, that's 1. Then let's go forward. Then we have plus 4 times 1, that's 4. K dot k is 1, that's 4, equals to 0. Okay, this is going to be leading us to a quadratic equation here. Yes, but nevertheless, let's just quickly solve that. You can actually use your calculator to solve quadratic equation. Yes, you can use it to solve quadratic equation, but to make it fast, let's just do it. It's a very simple quadratic equation. So here we'll be having our factor is 4 times 2, that's 8a squared. So what are we going to multiply together to give us, that will give us 4, or that will give us 8. And what are we going to, it's quite impossible. So let's just use our calculator. It's quite impossible. We have to use almighty formula. But quickly, let's just use our calculator. How to solve quadratic equation using your calculator. So this is just literally what you want to do. This is our A. In your calculator, you'll be asked for something like this. This is our B, and this is our C. So you will get there now. Let's go. So here we have it as this. First thing, you go to 5, you press 5. So then from here, which one actually looks like this equation that we have here? That is number 3. So that's number 3. It looks like this equation. So that's ax squared, can you see, bx, then c, 2, that's the power of 2. That's quadratic equation here. So let's take 3. You press 3 in your calculator. So it's going to be asking you this. So for this place here, you press this on this coefficient 2. So once you press 2, it will show on your calculator like this. Then you press equals to, this equals to button straight up. So when you press this equal to button, your 2 is already saved. Then this unknown shifts to the other side. So for B now, you press 2 because this is the unknown that is there, 2. The coefficient that is there, 2. So you press 2 again. So the 2 will be showing here, but when you press equals to, it will be showing on top. Then this box shifts to the other side. So what is on our C? We need to input our C. So C is 4. So we need to put 4 here. You press 4, then you press this equals to. So your 4 is now being saved. That's the last number. So how then do we solve? Then you press equals to. So you just press equals to. After pressing the last number, you press equals to. So meaning that our value for A is going to be 2. Don't forget, our value for A is going to be 2. There will be 1 here, there will also be 1 here. So our A is now, the first A, that's A1, is equals to minus 1 over 2 plus root 7 over 2i. This is like a complex number. So let's just press SD to change it to decimal for us. Okay, literally you still be having it in complex form, so don't worry. This is our first one, our A1. So our A2 is going to be, if you press our A2, what's our A2? Press equals to again. You press your equals to, you have our X2. So you have it as minus 1 over 2. You have it as minus 1 over 2. Are you seeing it? As minus 1 over 2 plus, no, this is not going to be minus square root of 7 over 2i. So this is our answer. So, but literally, this is our A. This is our A. The A here is going to be positive. The A here is going to be, this is what is actually changed, sign that was changed. So meaning that our A literally is minus 1 over 2 plus or minus, this quadratic equation, plus or minus root 7 over 2. plus or minus root 7 over 2. So this is literally our answer to this question. Root 7I. This is literally our answer to this question. So it looks like an unreasonable answer. That is why it is imaginary with this presence of this I. I simply means imaginary number. So it looks unreasonable, but that is just the solution to this question, and this will literally be the answer of A. This will actually literally be the answer of A. So don't forget to like, subscribe, share this video, and as well comment for more explanation. You have some other descriptions if you want to reach out to me in the description button. My WhatsApp link is there. So share this video to as many of your colleagues. So in the next episode I'll be solving number 7 and number 8 quickly. Solving number 7 and number 8. Don't forget to like this video. Thank you.